Alright, doing this problem called word search. Given an m cross n grid of characters, board, and a string word, return true if word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter may not be used more than once. So this is the grid, and we are searching for this word A, B, C, C, E, D. Now, if I have to search a word in the grid, obviously I'm interested in first of all I'll search for the first character, right? So whatever is the first character, A. So I'll go to the grid and I'll find A. I find A in the first position itself. Then from that guy, I'll just do a DFS sort of, right? And try and find the word, right? So from A, I go to, like, for example, all four directions, and then in one directions I get B. Then from B, I'll go in all four directions, but I wouldn't want to go back to the one I came from, so I will have to maintain that path. But okay, that's typical DFS. And then and from B, and then basically, so the summary is, uh, you take your grid, you go through the grid, and as soon as you find a character, as soon as you find a position which has the same character as the first character in the word, do a DFS from that, right? So for example, here you do a DFS from this, and you are able to find the word. And so that's it. In this case, you're looking for SEE. So you go through the grid, you look for S, you'll find this S. Now you do a DFS from this S looking for the word. When you go for DFS from this word, you do not find the next character E, you stop there. And then you go to this S, and again you do, so SC is not useful, SE is useful, but after E, you're not getting any other E. Here, SE you go, and then there is this position. So obviously when you're moving, you can also see you have to take care of the edge cases where you can't move out of the grid and all those sort of things. But essentially, that's a general idea, which is in the grid, you go through the grid. Whenever you're at a node whose character matches with the first character, do a DFS from that looking for the word, right? So let's do that. So we have I equals to 0, I less than product length, I plus plus, and then traverse the rows. I am interested if this board of ij matches with the first character of the word. Sorry, not j, the first character. Then I would do a DFS. So, and I'll return true or false from the DFS, telling that whether I was able to find or not. So I am passing board, I'm passing word, I'm passing I, I'm passing j. If that happens, then I will return true right away. And at the end of the things, I will return false. Now to do the DFS, as we mentioned, we can't go back to the previous thing. So we could define all those things maybe here itself. So I wanna maintain like in path or a stack of the words that I've seen. So the for example, if I go CES, then I have CES should be in my path, and then I remove them, right? The typical backtracking way. So I do Boolean. And I maybe will pass this as well, right? So I'll pass my in path. And I'll be calling this DFS recursively, so I might also want to pass in the index within the word that I'm looking at. So let's say I also pass, initially I'll pass it as 0, right? So the point is, while we're doing DFS, you have to ensure that the character at board ij matches the character at word at this index, right? And so we are looking at, we're using a Boolean, returning a Boolean from DFS. I have a character board. I have a string word. Sorry about that. I have, let's call them x and y, right? The index within the board, and what else? A boolean in path, and an index. Let's call it index, right? So one of the things is, when would I have found the word? I would have found the word if this index has reached the end, right? So if this index is, so that means I did DFS and I kept getting incrementing the index, and and finally I've found the exact the last till the I've reached till the last character of the word. In that case, just return true. I have found the word. What else? What are the cases where you want to return false? Hey, I can't find word from this specific path. One is if you're outside the board, right? If you go I less than 0, j less than 0, I greater than equals to dot length equals to. So if any of this happens, is there any more condition? One is you don't want to go back to the path you came from. So if you're already in path, if this guy is already in path, that means I can't create a loop. I can't go back to the same. I can't use the same character again. And I want to maintain that uh, the character at xy should equals the character at index in the word. If any of this, so but if this doesn't happen, right? So if any of this doesn't happen, then this path is not of no use to me. Return false. If this, if I'm here, that means I'm not reached the end. I'm at a valid position within the board, and I'm not reached. This is the first time in this path that I'm visiting this index, and this index matches the correct character in the word. All good. So then I'll call, hey, first let's add it in path. And then go to all the four different directions from here, right? So if I want to do all four different directions, I can just maybe do like I call the four as moves, and what are the four directions I can go to? I can define them here. So it would be, I can go from the current position. I can move in 0 minus 1 direction. I can move in 0 1 direction. I could move in 1 0 direction, or I could move in minus 1 0 direction, right? These are the four different directions I can move in. Let's try and go in all the four directions. For each move in moves, again we'll try DFS from all the four, and if any of the DFS returns true, we'll short circuit and return to there itself, right? So what do we pass? Board, word, x plus move 0, y plus move 1, and what? In path, sorry about that, and the next index, so index plus 1, right? It is happens a little true, and then we want to, this character we visited, and now we'll visit another direction. So this guy will, I will just mark it false, right? So this is the backtracking thing. Okay, now let's run and see if it works. Fix compilation errors, line number 24. Okay, some more errors, line number 3. What's the problem here? Cannot find symbol. Okay, spelling mistake somewhere. All right. Bunch of other errors. Let's fix them too. Line number 29. Uh, okay, we were calling them x and y. So x, y, x, and y. Okay, let's see if any more errors are there. A missing return statement. Okay, by default return false if you haven't returned true. And we get wrong answer though. Okay, let's do a code walkthrough. So this is the example, and we are to return true, but we're returning false. Let's quickly do a code walkthrough to find where the bug is. So we define the in path array, all good. We go through the board, and whenever so are we iterating correctly? Board.length, board 0.length, yeah. And whenever I find the character matching the first character, I do a DFS. I do board, I do word, I, J in path and 0. And if the DFS returns true, I return true. Looks fair. So we go here, we come with 0, 0 in path index. If the index, that's the condition that we should have reached, but unfortunately we didn't. So these are the, okay, I think a small typo might have caused problem. And another thing, it has to be the number of columns, which has to be looked at like that. Okay, let's, is this correct? Board dot length. All right, let's run again. Oh yeah, it will, the 3 test cases pass. Let's submit. And it seems to work. Now in the problem, it also says at the end, gives a follow-up. Could you use search pruning to make your solution faster with a larger board? So if you think about the time complexity currently, the time complexity is, hey, for each and every potentially, we could do, so for each and every index in the, each and every cell in the board, we might end up doing a DFS, like or a large number of, like depending upon the, in the worst case, for a large number of for a large number of cells in the grid, we might do a DFS, right? So the number of grids are m cross n, and DFS again, each will be like a exponential, right? 4 times. Um, so the idea of search pruning is, can we reduce the number of DFS that we are doing? And even before coming to that, can we also improve space complexity? So one of the things that we can do, there are multiple optimizations that can be done in this problem. One of the optimization is this in-path space that we are taking. It can be avoided. And the way it can be avoided is by using the existing grid itself. So essentially, when I'm making in path of xy is true, maybe I change the character in the board to something that is not a valid character. So that would be my distinguishing point, that hey, I've already visited it, right? And then I can revert it back here. So what I mean by that is, instead of doing like a in path of xy is true, let's save the character. And just instead of using a new space, just replace this board of xy to some special character, let's say star, right? And here we can change board of x, y back to the original value. And now this condition that we're saying, hey, what if I have already visited? Like if you have already visited, then now, because then this condition would never become true for the visited ones, because board of xy would become star, which will never match character in the word, because the character number is only uppercase and lowercase English characters, right? So we remove the need for in path xy by using this trick. So we can get rid of in path. We can get rid of in path from here. Get rid of in path from here. Sorry about that. No need for this condition. Not passing in path anymore. So that's how we can get rid of in path. Let's quickly submit and see if we have some compilation errors. We have a few, missed few commas, a comma here. Okay, submit again and see if I more. All right, so this works. So that was one optimization. that we could reduce the need for that in path. Other optimization is before even doing DFS or trying to do DFS, can we find out if it's even possible using doing a single pass of the word and single part of the board to find out if this word can be found in the board or not. And one of the ways to do it is we count the characters of all we find the count of all characters in word, and we find the count of all characters in board. And if for any character its count in board is less than count in word, that means it's just not possible to find the word in cache. For example, if your word contains C 5 times, but in your board C only occurs 2 times, it's impossible to find a word in board, right? So let's add that condition as well. So for that, you'll need to maintain a count of characters. Let's maintain an array. Let's call it word char count to new int. Now, typically, if it's a lowercase English characters, I would do 26, and then I will index using whatever the character is. I would index it using, like, I would give it to an index using this, right? But here it's uppercase and lowercase English characters. So for that, if you quickly take a look at the ASCII chart, we can see the uppercase characters has lower ASCII value than lowercase, right? So it actually starts from capital A, goes till capital Z, and then there are some bunch of other characters, and then small a till small z. So maybe we build an array from capital A to small z, right? Small middle, like few characters within is fine, but and then to give it an index, like convert the character to index, we'll subtract it the ASCII value of capital A, right? So we do instead of 26, we are defining an array from small z, like capital A to small z. So that's one, and we'll refer instead of minus small a, we'll refer minus capital A. So for each character in word, let's scan the count of each. So word char count, right, like that. And let's do the same for board as well. So we do the same for board. Let's traverse, do a single pass on board. And now the board char count of this character, which is right. So we get the characters in board and then board and word. And now we do that logic check. So go through each and every character, I equals to 0, I less than length, I plus. And if there is any character which occurs in board less than it occurs in word, then you just can't find, so you just return false for that case. That's like one optimization where if you can't find the answer, you just return faster. Okay, let's submit and see if there are any compilation errors. Let's fix those. There are a few. Let's fix. Line number 3, new, too many news. Okay, one new has to be removed. See if there are any more. All right, seems to work. And we do see the time of the has increased significantly. There is one more optimization here, which is, so essentially what we are doing here is we are doing the number of DFS depends upon the number of occurrences of the first character of word in the board, right? Like if A occurs 20 times, then at max I'll do 20 DFS, right? Correct. Now, when you're searching A, B, C, C, E, D, You could potentially also search for the reverse string, which is DECCBA, right? DECCBA. Now you see here in this string, A occurs two times. That means potentially you might have to do two DFS, right? If you're searching for the forward word, but if you're searching for the word reversed, D only occurs once. You can only do a single DFS, right? This would make sense if you have a bigger board and the frequency of the first character is much higher than the frequency of the last character, right? In which case, it might have been better to search for the reversed word, right? So, give an example. Let's say the first character is A, last character is D. If the frequency of the first character occurs 100 times in the big grid, so you potentially will do 100 DFI. But let's say the last character only occurs 5 times, then you could just do 5 DFS and find whether or not the word exists, right? So that's another criteria that we do. If the frequency of last character is lesser than the frequency of the first character, then the word to search, reverse it, because it will reduce the number of DFS that we might have to do. So let's add that optimization as well. So if the word count of the last character, word dot char at word dot length, this is the last character. I'm converting it into index. If this is lesser than the first character, which would be word dot char at 0 minus a, right? If this is lesser, everything handled correctly? I don't think so. Something is amiss. Okay, word dot char at 0 minus a. Yeah, now it's fine. If that's the case, then you want to reverse. So let's reverse the word. So char reverse equals to new char word dot length. So reversed of I equals to board of j, and you do word equals to new, convert it into a string, right? So you reverse the word. Let's submit this and see if this works as well. Get few errors. Let's check those errors. So okay, I think has to be like that. Word dot length has to be like that. Submit. Word of j, array required. It's an array. Oh, word j, you have to do word dot char at j. All right, submit. More errors. If condition, index out of bounds. Okay, minus stuff. All right, so this works as well. That is it.